Today we're going to look at some problems involving the Pythagorean theorem in application, so real world examples. So when we are doing application problems, there's a couple things that you want to do. First of all, we're going to read through the problem, we're going to underline what's important, because a lot of times there's a lot of fluff in there. We're going to identify what it's asking you to find, we're going to draw a right triangle and label it, we're going to use our Pythagorean theorem to solve. Okay, and again, what we talked about yesterday, we're going to talk about, does it make sense? Does our answer make sense? Okay, here's our first problem. It says, Jeremy goes to the Whitewater amusement park. While he's there, he decides to go down the park's huge water slide. If the slide is 92 feet high and the base of the slide is 69 feet from the pool, what's the length of the slide? All right, so there's a lot of junk information in here. So we know Jeremy's going to the water park. That doesn't really matter to us. He's there, he decides to go down the big slide. All right, so none of that's important. So let's look at some of the information. The slide is 92 feet high. Okay, so 92 feet high. So my height is going to be this side of the triangle. Then it says the base of the slide, so the base is 69 feet from the pool. So we have 69 feet here. It says, what is the length of the slide? So we're solving here for x. Okay, so now x, if this is my right triangle, this is my right angle, x has to be my hypotenuse. Okay, so we're going to use our Pythagorean theorem. So 92 squared plus 69 squared equals x squared. All right, so I'm going to type in 92 squared gives me 8464 plus 69 squared gives me 4761. Equals x squared. Need to add those two numbers together. I get 13,225 equals x squared. And then remember, we need to take our square root of both sides. And you should get x equals 115. Okay, so that means it's 115 feet long. So this slide that he's going down is 115 feet long. Okay, so does our answer make sense? Is it the longest side? Yes, it is, because 115 is greater than 92 and 69. Okay, let's look at another example. It says a ladder is 25 feet long. The ladder needs to reach a window that's 24 feet above the ground. How far away from the building should the bottom of the ladder be placed in order to reach the window? All right, so ladder is 25 feet long. Okay, so that's important information there. So the ladder is 25 feet long. So the ladder is leaning against the building. Okay, so we're really talking about this part right here. This is the ladder that's leaning against the building. Okay, so I could even like draw in the little ladder if you want me to. Right, here's our little steps. Okay, so this part here is 25 feet long. Okay, then it says it needs to reach a window that is 24 feet above the ground. So this part over here has to be 24. This time I'm going to solve for how far should the bottom of the ladder be placed in order to reach the window. So we're looking here for x. So now remember, my hypotenuse has to be c. So the 25 is my c value, my hypotenuse. So I have 24 squared plus x squared will equal 25 squared. Again, my hypotenuse is over there all by itself. All right, so 24 squared, that gives me 576 plus x squared equals 25 squared is 625. Now I have to get x by itself, so I need to subtract 576 from both sides. When I do that, I get x squared equals 49. So in order to get rid of my square, I need to take the square root of both sides. The square root of 49 is 7. Okay, so my answer is 7 feet. So it has to be 7 feet from the wall. Okay, example number 3 says a tent in the Cabela's catalog is described as having side lengths that measure 5 feet each and a base that measures 8 feet across. The height when standing in the middle of the tent is not listed, so how tall is the tent? All right, so how tall is the tent? That's what we want to know. I want to know this value right here. Okay, now it says in the magazine, it has described as having side lengths that measure 5 feet each. So the sides of my tent are here and here. Okay, now it also says that the base, so the entire base of the tent goes from all the way to the left, all the way to the right. That whole value is 8, which means then I need to split that evenly. So that means we're going to have 4 and 4 for both of those. So really, we only need to focus on one of these triangles. Okay, we only need to focus on one triangle because they're really, both triangles are congruent. Okay, so 5 is my hypotenuse. Right, 5 is my hypotenuse. Let me get a pen, okay. So then I would have x squared plus 4 squared equals 5 squared. Because this is my hypotenuse, that has to be C. So I have x squared plus 4 squared is 16 equals 5 squared is 25. I need to get x squared by itself, so I'm going to subtract 16 from both sides. So I have x squared equals 9. In order to get the x by itself, undo the square, I need to square root both sides. So I get x equals 3. So the height of the tent is 3 feet. So this height right here is 3 feet. That'd be a little tent. Would not want to stay in that tent. Okay, next example. The next one says the bottom of a triangular sail measures 6 feet in length and it is 3 feet above the deck of the boat. The diagonal of the sail measures 10 feet. How tall is the entire mast? Okay, so first of all, there's a lot of information in here. So how tall is the entire mast? So the mast is this whole piece right here. So it's a little bit more than the whole triangle. So it says the bottom of the sail measures 6 feet. Okay, so the bottom of the sail, the bottom is 6 feet. So this part here is 6 feet. All right, then it says it's 3 feet above the deck. So what that means is the 3 feet above the deck, that's just this little piece down here. That's just from here to here. Since the diagonal of the sail equals 10. So the diagonal of the sail is 10. So first thing we're going to solve for here is our missing side. Okay, so my hypotenuse is 10. So I have I have x squared plus 6 squared equals 10 squared. All right, so I'm just dealing with my triangle first. We're going to deal with that 3 later on. So I have x squared plus 36. 6 squared is 36 equals 10 squared is 100. To get x squared by itself, I need to subtract 36 from both sides. So I have x squared equals 64. To get rid of the squared, I need to take the square root of both sides. So the square root of 64 is 8. So this part is 8 feet tall. Okay, but now the question is, remember we have to answer that final question, how tall is the entire mast of the sailboat? So I want this entire length right here. So really, I'm going to have 8 feet plus the 3 feet that it's standing off the deck. So it's a total of 11 feet. Okay, last problem. A plane flies south 133 miles south, then heads 156 miles west. If the plane would take the most direct route back to the airport, how far would it need to fly? All right, so this time I didn't give you a triangle, but it says the plane flies 133 miles south. So it's going down in this direction 133 miles. And then it heads west 156 miles. So it wants to know if it were to fly back to its original location, how far is that flight? All right, so here's my right triangle. So when you go like north to west or north to east or south to west and south to east, that's a 90-degree angle. Okay, so we have 133 squared plus 156 squared equals x squared. All right, so 133 squared gives me 17,689. Then 156 squared, 24,336 equals x squared. So these are big numbers here. So I need to add those together. So combining my like terms here. So I'm taking the 17,000 number and the 24,000 number and adding them together. I have 42,025 equals x squared. Now in order to get rid of my squared, I need to square root it. So I get x equals 205. So it's 205 miles back to the original spot. All right, so for homework, I'm going to have you work on this worksheet. It has 8 problems on there, I think it's 8 problems, very similar to what we're doing here. If you need to, go back and rewatch the video, slow it down or pause it. Just take your time going through the video. The problems, again, are very similar.